I bet you think you're so good at maths, don't you? Well then, what's 2 to the 64? Come on, I'm waiting. When you ask a human to do this, it would seem like an impossible task. But this little box with buttons on it can find the answer in just 0.1 seconds, which is about as fast as Nikocado Avocado's weight loss journey.
I am the villain.
You can actually work this out by multiplying 64 2's together by hand, or if you're smart about it, by squaring 2 7 times. While that works for simple whole numbers, what about more complex problems like pi to the 1.5 or 7.3 to the 2.2? Well, for that, calculators use something called the Taylor series, which gives us an approximation for e to the x. Basically, a really smart man called Brooke Taylor with a really big brain realised that e to the x equals 1 plus x plus 1 over 2 factorial x squared plus 1 over 3 factorial x cubed and so on. Don't ask me how. And this is what calculators use today to evaluate any value of e to the x. So if we plug in x equals 1.5 for example, all our calculator has to do is raise it to the power of integers, which it already knows how to do, and then multiply it by 1 over an integer factorial. While that might sound difficult for a human, for a computer, multiplying and dividing integers can be done millions of times per second. But what about when the base isn't e? Let's say we want to find 2 to the power of 2.7. Remember when I said that if you want to work out 2 to the 64 by hand, then you could either multiply 64 2's together or you could square 2 7 times. Well, that's because when you raise something to the power multiple times, the powers multiply together. So if you raise 2 to the power 2, then raise that to the power 2, you really just raise it to the power 4 because these 2's multiply together. Now you can also do the same thing but backwards, so if we have 4 to the 32, we know that 4 equals 2 to the 2, so we can replace that with 2 to the 2, and now we're just raising a power to another power, so we can multiply them together, which tells us that 4 to the 32 equals 2 to the 64. But we want to express 2 to the 64 as e to the x, so that our calculator can use the Taylor series to find the answer, so we need to break down this 2 into e to the power of something. Any ideas? Well, it's not actually a simple integer. It turns out that this number is something we call the natural logarithm of 2, or ln2, which is about 0.69. So instead of writing 2, we can write e to the ln2 and then raise all that to the power 64. Or we can just multiply ln2 by 64 to get e to the 64 ln2, which is roughly e to the 44.36. Then we can just plug this into the Taylor series and find our answer. But how does it find the natural log? I've found it. No, I'm not talking about a log made out of wood. I'm talking about a mathematical natural log. Maybe if our school systems were better at teaching maths, you'd know that by now. But that's what Brilliant's for. Brilliant is an interactive platform where you can learn by actually doing, instead of just listening and then regurgitating onto an exam paper. They've got thousands of hands-on lessons in maths, data analysis, programming, and even AI. There's also a mobile version so you can learn on the go. Instead of just passively watching like you all are, you lazy gits, you get to play with the concepts, you know, fiddle around with the knobs and stuff, which is 6 times more effective than watching lectures. If you want to enhance your problem-solving ability, Brilliant has mathematics courses built for any level. Or if you want to start building programs on day one, Brilliant has a built-in drag-and-drop editor. If you want to try Brilliant for free, click the link in the description for a 30-day free trial plus 20% off on an annual premium subscription. The calculator finds ln2 using Chebyshev polynomials, and to save me from having to repeat myself, I've already explained Chebyshev polynomials in my previous video, How Do Calculators Find Square Roots? What are you looking at? Click the video.